Is that it? Okay. I accidentally pressed the mute. I will start over. Hopefully, can someone give me a confirmation you can hear me now? I think I accidentally pressed my mute button. Okay. Yeah, I think something went funny when I put that. Okay, so let me start over. Um, so what we did on Tuesday is we completed the plan struct, and this lab 14 is introducing you to the idea of a struct. But we're also going to continue practicing looping algorithms in algorithms on slices. So the added complication here is that we're being introduced to structs, and then we have to create instances of them and put them in a slice and then do stuff. So there's the struct. This piece, this describe, we call a method. And I'll show you in main how methods are different from functions, but methods are basically functions that are attached to a struct. So they mostly look the same, but usually you end up writing them around the fields of a struct. And then we did most moons, and that's where we left off. So most moons takes a slice of planets, and then it identifies the planet with the most moons on it. The other thing that we did, I'll scroll down, is we created a whole bunch of instances using data from the internet. Mercury, Venus, Mars, Jupiter, Saturn, and so on. Then we took all those instances and we loaded them into a slice. The reason we did this, put all those planets in a slice, is because it makes it so much easier to process them. So if I want to know which planet has the most moons, the easiest way to do that is put a whole bunch of planets in a slice and then loop through the slice looking for the planet with the most moons. So that's why we did the slices, because then we can write very efficient algorithms. Alright, so this was already here for us, but this is taking the slice that we have populated with planets, pulling out one planet at a time. There's some kind of lagginess going on. Hopefully it's not affecting you. Loop through, ranged over planets to get one planet at a time, and then we use the describe method on each planet. And notice how the method is different from a function, because the method needs an instance of a struct to execute. So we take an instance of a planet and describe it. And then down here is where we did most moons, because that's where the note for it was. Okay, so now we're going to go implement the rest of these. They're going to be very similar, so sorry about that. It's kind of repetitive. So coldest planet. So we're going to use the same algorithm we've been using. When you have a problem like this, where you have a slice or an array of something, and you need to identify a minimum or a maximum value, one of the easiest ways to do that is to assume that the first one is the one that you want, and then loop through the remaining elements and look for something that proves you wrong. So I'm going to assume that the first planet is the coldest, and then I'm going to loop through the rest of them using a counting loop. The reason why I'm using a counting loop is because that allows me to skip past the first one. So I can start at element 1 as opposed to element 0, because I already picked up element 0 and assumed it was the coldest. So the len of the slice of planets. So we'll take the next planet we see as we're looping, and we will get its mean temperature. If that is less than the mean temperature of what I think is the coldest planet, then that must be the coldest planet. So I replace what I thought was the coldest planet with this new planet that seems to have a smaller mean temperature. Then when I get to the end, I'll put a label. So coldest planet. I'm not putting a new line here so that the describe ends up right next to it. And then I will take the cold planet and describe it. Same as we did with the most moons. Oh, let me move this thing. It's getting under my arm. Okay, so I'm going to go down to main. But notice it's the same algorithm as we did most moons. So we took the first one, just like we did with most moons. We looped through the remaining, so we started I at 1, and then we looked for a planet that proves us wrong. So if I can in fact find a planet whose mean temperature is less than what I thought was the cold planet, well, that must be the cold planet. Let's go call that function in main. So somewhere there's a note in main that says call coldest planet, pass planets. So it already has planets in there, so that's all good. And let's go run it. So there's the coldest planet, which is Pluto, which makes sense. It's way the heck out there. And we'll just keep going. Hottest planet. It's going to be a very similar algorithm, of course. So the hot planet, we will assume to be the first. And then we will loop through the remaining, which is why I use a counting loop again, because I can skip the first with a counting loop. With the range loop, I can't skip the first element. It automatically hits all of them, including the first. So with a counting loop, I can skip the first one, and I had already used the first one. If, so the one that I'm looping through, mean temperature, now is greater than the hot planet's mean temperature, then I will make that B. So now the hot planet is that one, because it has a higher mean temperature. Same algorithm. We did this for minimum on project 3, like finding the minimum in a slice of floats. We did it for maximum as well, which is really all this is. This is the maximum mean temperature, whereas coldest planet is the minimum mean temperature. So do the same setup. Hottest planet. And I did not put a new line because I want the little tag on the same line as the describe for it, and then I will use describe on it to see the details. Well, it's not going to do it if you don't call it, so let me scroll down to main, hottest planet. I'm letting Adam fill in the blanks for me there, by the way. So it popped up a recommendation. I hit enter to accept it, and it just filled it in perfectly like I would want it. So I'm pretty happy with that. Okay, hottest planet is Venus. Makes sense. Alright, where does that get us? Least weight, most weight. Okay, so now we're down to the weight ones. So the first problem is just a translation problem. So it's given me the formula for calculating. So given someone's weight on Earth, it will calculate your weight on some other planet. Let me see if I can stretch out my editor just a little bit. I believe that I can, without messing up your view of things. Well, I'm not happy with that. Alright, that's about as good as I'm going to get. Okay, so we need to translate this formula we've been given to match what we have available to us in the function. So in the function we have a planet and all of the fields for that planet, like the mean temperature and gravity and things like that. And we have this variable or parameter called Earth weight. So we just need to make sure all those things match up. Weight on another planet, that's fine. I will create that variable. Weight on Earth in the given formula doesn't match the name and the parameter, so I'm just going to switch out for Earth weight so that what I actually have as a parameter matches what I'm using in the formula. Planet gravity, well, I have a planet, so I'm going to have to get its gravity. And I'm using the little pop-up there and hitting enter. And then Earth gravity is at the top. So if I scroll up to the top, we'll find that there should be an Earth gravity up there. Here it is. So this is a constant, and all that means is that it's a constant, like pi is a constant. So this has been created and left here so that I can use Earth gravity whenever I need that value. But because it's listed as a constant, it won't change, which makes sense. Earth's gravity is roughly a constant, at least for our purposes. Okay, so Earth gravity is what it's called here. So I just make sure in my calculate weight function that it's still called Earth gravity, which it is, so that's good. So I do the calculation and then I return it, because this function is supposed to return. And it even says, accepts a planet and a weight, computes and returns your weight on some other planet. So it factors in what Earth's gravity is relative to what that planet's gravity, and then computes what you would roughly weigh on that other planet. That's it for that one. I'm going to scroll down to main. I don't think I'm supposed to do anything. Not yet. So we need least weight or most weight. We'll do least weight first. Okay. So least weight, what it's supposed to do is take your Earth weight and then cycle through the planets and find the planet where you would weigh the least based on your Earth weight. So there's a planet out there whose gravity is lower than Earth, and thus you would weigh less. And one of them you would weigh the least on. And there's a hint here that says use calculate weight to help. So what I need to be able to do is cycle through these planets and calculate my weight on that planet and compare it to the other planets. So this is another sort of find the minimum, find the maximum thing. Meaning, I'm just going to assume that I would weigh the least on the first planet, and then same algorithm, see if I can prove that to be wrong. So I'm going to loop through the remainder. Looking for one where my calculated weight is less than this planet. So the tricky part here is that I have to calculate my weight on each planet and compare it to the planet where I think I weigh the least on. So the way you do that is you simply call the function here. So I'm going to calculate my weight on the next planet that I get from the loop. I have to pass it my Earth weight for it to do the formula. So this is going to calculate my weight on each planet in the loop. And what I'm looking for is a weight that is less than, and I'm going to put this on the next line down, I think. Yeah, because it won't fit very well. I want to see if that's less than my calculated weight on the planet that I think I weigh the least on. So this planet. Same Earth weight though, so no matter what planet I'm talking about, the calculate weight needs my Earth weight to figure out how much I'd weigh on it. So take each planet after the first one, calculate the weight, and then I compare that to see if it's less than my calculated weight on what I think is the place where I weigh the least. If I find a planet where I would weigh less, then that becomes my least weight planet. And then I'm going to cheat because Nate asked a really cool question yesterday, so I'm going to cheat and use his idea. So here's what I did yesterday, and then he made a good point, so then I'll show you how we fixed it. Okay, so once I get to the end here, then I'm going to say least weight so still a label, and then I'll do a least weight planet.describe. But yesterday, Nate had a cool idea, which is, well, it'd be cool if you could see how much that weight is. Like, how much do you weigh on the planet where you weigh the least? Because this describe will not show you that. It's just going to show you the basic stats on that planet. So what we did is we enhanced our little label here to say, here's your least weight. And then we plugged in your calculated weight on that least weight planet. Same Earth weight. So that gets pretty long. I'm going to drop it to the next line down, which you're allowed to do, and go. So anyway, this is all one output, so just be careful about the parentheses. But this was a cool idea that Nate had yesterday, which is let's show them how much they weigh on that planet. So we'll just recalculate how much they weigh on that planet and print it out, which is cool. And then provide the additional stats about that planet. So I'm going to go try it out in main. But you notice it's the same algorithm. Take the first one and then look through the rest of them to prove yourself wrong. Okay, so where is least weight planet? Okay, so here in main, we're going to have to know how much they weigh, so I'm going to give myself a weight, which will be a float 64, and then I'm going to have to ask them. Printf, how much do you weigh? And then I'll scan in. Their weight. So now I have a weight I can pass in to least weight. So now when I call least weight, I can pass in the planets that I have set up plus the weight that they just typed in. The words don't have to match, so I can call it weight here, and the function can call it Earth weight, and that's fine. Let's see which planet that is. So I would weigh the least on Pluto. Also makes sense because that's a very, very small place. So I would weigh just short of 11 pounds on Pluto. I imagine I could probably jump pretty high. I'm not sure though. Okay, so one more algorithm here, which is where would I weigh the most? So same algorithm. Just assume that the first one is where I would weigh the most, index 0, and then loop through the remaining, starting at 1 for all the rest of the planets. And then I'm going to calculate my weight on that planet with the given Earth weight, looking for where that is greater than what I thought was the place where I weigh the most. You could do some copying and pasting here probably. So it's the same algorithm, except for now I want to see if I can find a planet that's actually more than what I thought was where I weighed the most. So that is now the most weight planet. So if this one that I'm calculating gives me a higher weight, then it becomes the high weight one. And then I'm just going to do the same kind of setup. So for it, most weight, I'll put the little extra display, which I think is a really nice touch. So that's the first part, and then the second part is just to describe it. So you get the extra details plus the calculated weight on that planet. Now I did that one quite a bit faster because it's somewhat repetitive. But I'm going to hit pause for a second if anyone's trying to sort of motor alongside me. The last step will be to call it. The thing to be on the lookout here for on these two is because I broke them up across multiple lines, like in two places right here with this comparison. And then right here with this printf, those are broken across two lines. So just be careful that you're not getting mismatched curly braces or parentheses because of that. You'll get errors, but just kind of watch for that. And if you're in doubt, just smush them all up on one line. I just didn't do it because I can't show it to you on the screen as well. So the last thing is to call it somewhere down here, most weight. So I don't need to ask them for their weight again because that's not going to change. So I'll just take the same weight that they punched in and just send it along to that other function and tell them where they weigh the most. Goodness, 354 pounds I would weigh on Jupiter, which means I would have trouble moving around. I'm sure my legs would feel heavy. Okay, so that was a little bit of practice with structs. It doesn't probably feel like it, but the nice thing about structs is that I have all this information and I can access different pieces of the information when I want to. So I can access the mean temperature when I want to, or the gravity when I want to. And every planet carries with it all of that information, so that's quite nice. And then with my describe method allows me to just sort of quickly say planet.describe and get formatted details about a planet. Okay, so that's lab 14. The rest of the time we can do whatever you'd like to do with the time. If you have questions or if you want to see me sort of start to build up one of the project options. If you're starting on the C++ bootcamp, I'm happy to answer questions about that. Anything that you like. We can. Yeah. So I'll go ahead and open up Lab 15. And anybody who has questions about other stuff, feel free to ask. Let me go grab it. Okay, no, you know what I'll do? Let me go get it off a browser and plug it in here. That way I don't destroy any original copies of it. Lab 15. Go code. Okay. Go. Okay. So Lab 15 is doing a lot more methods. And I know this because I see a lot of functions that have movie in front of them. The star in here, it only affects one little thing. You won't really notice when you're coding it, but if you were to take it out, you'd definitely notice that it wasn't there anymore. So one thing I'll just sort of tell you as a hint is if you're experimenting, take the star out and see what changes. It doesn't change the way you code it, but it does change what the code will and won't do. That sounds confusing, but I'll actually talk about it a little bit next week. Anyway, these are a bunch of methods, so it looks like function add like view, except for it has a movie in front of it, which means that it's going to be movie dot add like view. Just like dislike view, movie dot add dislike view. And notice that all of these are methods. Some of these methods, like this one's crazy looking, because it requires a movie to use it, like jaws dot get percentage like, but it also then computes and returns a float. So there's some new stuff there. Let's start with this one though. So this star here, we'll talk about it more next week. it requires that you use a couple of extra symbols in the code, but what you get with a star movie, you can call it an asterisk, but a lot of us just call it a star. A star movie gives you a movie that you can alter over time. So if I took the star off, I would get a movie that I can't change. Um, so these movies, for example, have likes and dislikes and views, and you'd like to be able to increment the likes or increment the dislikes and increment the views, like a Netflix movie. But you can't actually change these things with a regular movie. If you want to be able to change information about a movie, you need a star movie to do that. Sounds weird, but that's what that's doing there. Oops. Is that I want to give myself a movie that I can actually alter its information over time. Okay, so what we return, there's a couple of ways to do this. I'll show you the way that I'll show you two ways to do this. So one is to make yourself a movie, which is going to look like this, and then you need to make sure that things go in order. So title, genre, likes, dislikes, views. So the title will be this title. The genre will be this genre, the parameter. And then likes, dislikes, and views should all be 0. So I can literally just say, well, I want 0 likes to start, 0 dislikes to start, 0 views to start. These things go in order from left to right, that you see them in the struct from top to bottom. Okay, so that's most of it. Now the trick here is that I want an editable movie. And the way to turn this movie into an editable movie is to use an ampersand. So this is going to be confusing at first. You're going to see it again in C++. By putting the ampersand in front of movie, I now have a star movie, an editable movie. And I know that's confusing, that it's two different symbols. Unfortunately, just the way that it works. When I make a movie, if I want it to be editable, I put an ampersand in front of it, and what I return is a star movie. This will make more sense when we have more time to talk about it, but that's what that's going to look like, and then I return that movie, that editable movie that I created. So it's just sort of two halves of the same coin. To create it and make it editable, you use the ampersand, and then to return it as editable, you use the star. Just sort of two steps. So anyway, that's one way to do it, and then I'll pause for a second and I'll show you what I would do is just eliminate the thing in the middle. You don't really need this separate movie unless you want it there. You can just cut straight to the chase and just directly build it like this. So I'll just make it editable and immediately return it, and that pairs up nicely with the star movie part. I don't know why I keep doing save. So anyway, that is how you make an editable movie, which is what the star and the ampersand are all about, is I want to be able to edit this thing. Okay, so I'll skip around. Let's do one of these first. So this star here, all that means right now is that if I do anything to M's data, it will change M's data. So if I'm supposed to add a like view, well, all I need to do here is go to M, grab its likes. Oh, it needs to increment views and likes. So I'll increment its views, and I will increment its likes. I keep hitting save. Well, because I want to. Apparently I want to hit save, so let me just empower myself to do that. Okay, so do you notice this code doesn't change? It's still m dot field, and then I do math on the field, and m dot field, and then do math on the field. This will count up likes by 1, count up views by 1. If I took this star out, then the math actually doesn't take. The movie actually becomes not editable, and any edits that I try to make, like incrementing the views and the likes, won't take. So I have to use a star here to make sure that the increments both take. And we can experiment that and see, but I'll probably do that next week, and you'll see it then. Okay, so I'm going to skip add dislike view because that's so similar. Let's go to get percentage likes and do a little bit of math with it. In this case, I don't actually need this to be a star, but it makes life easier if everything is a star. Once you get going with these star movies, it's easiest if everything is a star movie. So that's why they all are. Get percentage likes. So I'm going to compute it. So percent likes equals, so what is it? It's likes against views, right? So it will be between 0 and 100. So it will be, I'm going to have to floatify this to do this. So I will get the movie's likes divided by the movie's views. And then I'm going to have to multiply that by 100. And check my math, you guys, make sure I do these in the right order. So if I have 1 like against 4 views, that's going to be 0.25 times 100 will be 25, like 25%. And then I'll return the percent likes. Now what I would normally do is just get rid of the middleman here. So I don't really need the middleman. I'll just cut to the chase and just return the calculation. The fun one with the new fun technique is the toString one, which I think Amanda's already done the sprintf, which is one of the cooler things to discover. This one's tested, so you implement these with the test file downloaded and then do a go test. So this is enough probably to get you pretty far along, because that sort of gives you a sense of how to implement these others. And then toString has a new technique that we haven't done yet. Well, not all of us have done. Because I'm just doing the calculation and returning. So you don't really need a variable for that. I can just return, it'll just run the calculation and return the result directly, as opposed to putting it into a variable first and then returning the variable. I can just have it compute the result and return the computed value directly. You could do it either way that you want to. I usually just eliminate the extra variable and just return the computed result. That's interesting. You get an OK. I don't know. Is there a test file there? Maybe there's not a test file there. You should you should, in theory, get a pass. Let me get to that spot. What's today, May 7? I'd like to figure out how to replicate what you have to see if I can get an OK instead of a pass. I feel like you might get an OK if there's no test present. You do, well, let's just try. What happens if I do a go test? Okay, well, if I could do a go test with no files, so I'm going to try an experiment here. I'm going to save this Um, and I'm going to have no test. No, if I have no test file, then it doesn't say okay, I get a question mark. So I don't know. That's interesting. What the okay means. Yeah, please do. Email those to me and let me try it out because I'm curious about that. And I'll put them in a little experiment folder and try it out because that's interesting. I don't know what that is. And then I'm going to put it in that little experiment folder I just made. So while I'm waiting uh, for her files to come in, I'm happy to answer other questions. Anyone wants to see demos? I didn't have good vending machine demos, but I could build one. Well, the dislikes, just okay. I'll go pull the emails. The dislikes, make sure that you're incrementing both the dislikes and the views. Make sure that you're incrementing the right things. So dislikes should go up by one, and so should likes. Okay, so now I have 15.go. Save as. Yeah, it's okay. It's okay to do it differently. I'm gonna go now try it. So now I have yours. Go test. It says okay. Let's try it with dash V. So I'm gonna try it in verbose mode and see if I see anything different. Run test new movie. Something feels funny here. Test new movie. Hmm. So this is interesting because when it did it in verbose mode, it only ran test new movie and then stop. Okay, so something's wrong. It must be crashing on test new movie. Um, so let's go look at code, shall we? So test new movie. Yeah, that should work. It likes. Well, let's reset this because these methods should not be returning things. So they don't have to return things because the star movie already takes care of that problem for add like and add dislike. So I'm gonna take those off Now I'm getting some complaints, but that's just because I have another source file sitting in there. Oh, there's an exit in here. Okay. Ah. So that was a good idea. But let's not exit. That's probably causing the test to drop out. But I think that you have something that I don't have that's important. Um, percent likes. Now, where's that coming from? Percent likes. Something's funny about that. I think we need to touch this one up, but I think that this is important. So let's return nothing there. And then, well, let's do it this way. Here's what I would do to sort of match your code. So you're looking at that denominator, which is smart. I didn't think of that, actually. So if there's no views, I can't compute it. I'll just say 0. So I think that the test is probably crashing. Let's try that kind of update. I'm just going to real quickly do that. Instead of the exits, which is probably, so you were smart to look for 0 views, that divide by 0 problem. But what we want to do instead of exiting the program is just make sure that we're sending back a 0 in those cases. So that was super smart, and I completely missed that. Well, now I'm going to look smart next week. Movie want, where's this at? Line 40. Okay, let's see what's on line 40. Oh yeah, that's my fault. So we don't need to return things. That'll just do its own thing. There we go. Okay. So yeah, so it was not crashing. It was those exits. So that was because you thought to do that. It actually exposed something that I overlooked. So that was super awesome. I forgot to deal with that. What if you have a 0 denominator? What happens? So totally keep that. Yeah. So these methods don't need returns on them because the star movie means they'll just alter the movie that got us here. So this is good because that's catching the divide by 0 problem, which would have hurt. Now the other thing is, and you might have seen the difference here, likes and dislikes. Alright, so it's failing these percentage-wise. So the issue here on percentage likes and dislikes, this one's tricky, but if you do, what's going to happen right here is it's going to run this division on these two integers before it ever floatifies anything. So what you need to do is floatify them separately. So you need to get them to be floats before you then combine them together into that division, or you end up losing data. It's going to run that division first. Yeah, so notice that the likes one now goes right through. And the reason why it's failing the to string is probably because the dislikes one needs to be floatified before you do the math. I'm betting. Okay, so we're passing everything except for, so expected Godzilla action, 4 views, 75% likes. Got Godzilla action, 4 views, 0% likes. Why would that be 0% likes? Views 0. I'm looking at why that one would fail. Oh, if you're still here, Nate, she's got this sprintf trick, which is like this the perfect thing to solve this to string part of the problem. We'll talk about this next week, but if you're here watching and you see this, this is like exactly the thing you want to solve this problem, is this sprintf thing. It's super cool. All right, why are we failing? Why are we forgot? Why is that saying 0% likes when there's 4 views? Likes, views, likes, views, likes, dislikes, views. It's all perfect. Likes, else percent likes, dislikes, percent dislikes. Seems all okay to me. Why is that one failing? That's on line 97 in the test. So there's 3 likes and 1 dislike. Should have been 75%. Why isn't it? And we got 0. Why did we get 0? Ah, okay. I see it. Last thing. So right here, this percent likes right here, probably have that as a global or something. Yeah, so we don't need those. Let's get rid of those globals. So down here, what you need to do is you need to use your movie dot get percentage like. So get the computed value right here on your toString. Yeah, that's everybody passing. So I'll try to remember to credit you for that, because I have a feeling that I wrote that test to expose that problem and I forgot to deal with it. So good job on that. Anyone else who's watching, what she's doing here, if views is 0, then trying to divide by views is a huge problem. So she's got an if statement here to handle the problem where if I have 0 views, well, I can't divide by that, so I just better say, I guess it was 0%. So that was really good, and I missed that. Okay, so that explains it, which is interesting. So it was either the exits were triggering or it was crashing somewhere, but I think it's because you had the right idea to check for the 0 denominator, but we wanted to just return a 0 value instead of exit there. So that's cool, and now I'm going to get those perfect next week when we talk about this loud, because I will remember that. I'm betting you in the test that I actually looked for that. Yep. Right there in that first part of the test, it's looking for 0%. And if there's no views, then that would totally crash if you didn't expect that. So, yeah, that's good. So anyway, hopefully you saw where I made a few changes to sort of match it up perfectly with what the test was looking for. Oh, is it falling off? It's falling off. Oh, it's a, woo, okay. I don't know when I did that, but I did do that. Let me get it back under control first, and then I'll stretch it out. I'll scroll. Okay, so now it doesn't overlap. So now let me scroll it over so you can see that piece. So I changed this was referencing a global, so I deleted the two globals and just did a new calculation here, which is what we want because the test may have been looking to see to pick that kind of thing off. Like, can it catch you not having calculated that? I guess we could, here, let's do this. Sometimes when I get a super long line like that, I break it up. So notice here that I go to the comma on this line, and then I just let everything else fall down to the next line. Well, we'll get out of that habit. Sometimes there's good argument to be made for using a global, but generally try to develop it as being not the thing that your instincts lead you to. So that's the thing to work on, is to make your instinct be not to use globals, and then force yourself to overcome your instinct to use a global, because sometimes it's okay to use them. Oh, does it? Um, it can make a difference, like where you do the break. So I usually break after a comma if possible. But if it gives you an error, then just bring it back up to the line above, and don't get stuck on silly stuff like that, I'd say. All right, Nate, let me get yours and see if we can find the issue with it. Okay, so that one's good. Oh, I see the issue here. Do you see it? So this thing that you're returning in this function, isn't anything. I think what you mean to be returning is this thing. Yeah, that's another one of those things. The plus plus and the plus equals, they're literally exactly the same thing. I'm a lazy typist, so I find plus plus faster, but there's in that case there's like literally no difference. It's totally a preference. Yeah, you're gonna fail. So remember what we were talking about with Amanda's code. There's a thing you got to look out for here. So this thing could be a problem if you're not careful. And more specifically, this thing could be a problem. So I'm going to show you Amanda's, Nate. So here's hers. And notice that she does something to be careful with the number of views. And the test is going to fail if you don't do this. Honestly, next week, I'm probably going to make this mistake on purpose and then fail the test and then sort of talk anybody who's watching the video through the the reasoning behind why the test would fail without this test right here. It's possible. Yeah, I found the nearest instructions I could, and they're probably written for old uh, Windows. I was hoping that would get you close enough uh, for downloading and installing the C++ stuff. Yeah, the replet should work fine. Yeah, I think you can even do multiple file stuff. So yeah, that's a good fallback. But in doing the C++ install is a pain without someone to guide you. CodeBlocks is good. You can use CodeBlocks. I haven't used it in a few years, so I didn't have a chance to evaluate it. But if it works and you like it, go for it. Because it comes, in theory, when you download it, it already has everything bundled with it that you need. And you can ask, by the way, if you're working on any of those things in C++. I'm happy to. Yeah, please do that because I'm gonna have everybody do a couple of C++ labs. So that'd be awesome to have a link to. What is it? Bucky's? Do you remember off the top of your head whose videos they are? I'm just curious. That's the only one I know off the top of my head is Bucky's actually. Oh, that's cool. I like those. I've done this for other languages where they sort of have a one just sort of work through one video. Oh, that's awesome. Yeah, if you would, that'd be great if you link that into put that link in Discord. Well, which one are you failing, Nate? Is it dislikes? And if it is, show us the code. Yeah, it seems fine. I'll plug those in and try them from over here. So let's do a percent. What was that? Percent likes. Oh, so the pairing you're sending me, Nate, you're sending me an add dislike and a percentage likes. So make sure that you're implementing all the matching pieces. Uh, so if you're only doing an add dislike view and then you have a get percentage likes, that ain't gonna help. You probably need to do both of the add, so make sure that you also get the add like view. So implement that one if you haven't, because percentage likes relies on both of those things being there. So make sure you get both of these and then run the test again, because this code, yeah, looks fine. Well, I don't see anything wrong with it. I'll plug them in and see if I pass with them. That's percentage likes. And then I'll get the add likes. Well, we already know that you have those. Dislikes and views. Yeah, those all pass. So they should be passing. Yeah, good idea. Check like the numerators in the right place. But this passes for me, so. But if you're doing get percentage dislikes, then she's probably correct that there's something mismatched in there. And let us know if you found it, Nate. Your percentage likes is perfect, so it's ready to go. Maybe it's the dislikes one that's, and she's probably right that you've got something maybe mixed up where you have likes where you should have, or dislikes, likes where you should have dislikes or something like that. And make sure that you have views as the denominator, of course. And also double check your add like and add dislike, like she said, and make sure that those are using the right variables. Ah, good. All right. Feels good. Okay. Does anybody, before I sign off, does anyone have any additional uh, questions or thoughts or anything? So as always, I appreciate you being here and interacting with me and helping each other and me out. Thank you, Amanda, for the checking for 0 likes, that's a huge deal. A lot of those tests would fail without that. So it's going to look like I'm super smart next week when I just sort of seamlessly deal with that. So thanks for that, and thanks for being here. So both of you, I say both of you, the two people I'm chatting with, but there's other people here. So I hope all of you have a good weekend. I'll be back on Tuesday at 2 p.m., which is the start of the last 2 weeks of sort of lab and project work, and then the final week of class is I will have you turning in a couple of things, but hopefully you don't find it stressful and you find it interesting to get a feel for how a different programming language works. So I think that's it. See you next week.